Today's lesson, we're going to be talking about sigma notation. First of all, what is sigma? Sigma is this Greek letter you see right here. Anyone ever see sigma before? Yes. Anyone ever use Microsoft Excel? Anyone know what sigma means? Absolutely, Alyssa. Yeah, sigma means you're calculating the sum. Okay, so we're going to be adding terms. The index, okay, could be n, could be I. Sometimes you'll see k for the index. This is the first value, or you're going to start by putting a 1 in for n. This is where you stop. This is the last value. So usually there's a number up here. Okay? And this right here represents the general term. So you may see something that looks like this. It might go from I equals 1 to perhaps 5. And maybe you have the general term 3 times I plus 2, something like that. Okay? Or perhaps the index is a k. And you're going up to n, and your general term is perhaps k squared minus 1. But know that the Greek letter sigma means that you are calculating a sum. All right? First question. Here we have it says for the sequence 1, 2, 4, 8, 16, 32, 64, there is an associated sum called a series. That's what we've been working with the last few days, a series and sequence. The Greek symbol sigma, that's this letter, is used to write the series in compact form. So it's just a shorthand way or a shorter way of writing a series. So instead of writing 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, which didn't take me that long because there's only 7 terms, I could write it like this. Okay? The advantage to sigma notation comes when you have like 20 terms or 50 terms or 100 terms. All right, let's understand how they went from this to this. How do they get this general term? Remember, this right here is the general term. Well, let's think about how we found the general term last week when we were talking about arithmetic sequences and geometric sequences. First of all, what type of sequence is this or series is this? What's the A value? First term would be 1, wicked. Does it have a common ratio or a common difference? Common difference, let's check. 2 minus 1, that's 1. 4 minus 2, that's 2. It's got a common ratio, nice recovery. Okay, 2 divided by 1, 4 divided by 2, 8 divided by 4, 16 divided by 8, 32 divided by 16, and 64 divided by 32. What do you get every time? What does that equal? It equals 2. So A is 1 and R is 2. So I know this is geometric. Agreed? How do you find the general term for a geometric sequence or a geometric series? We use this formula. And when you want the general term, you just fill A and R in and you leave N alone. A is a 1, R is a 2. Now know that I can actually simplify this. Does this 1 really change anything? I would have to figure out my exponent, raise my base of 2 to that exponent, and then multiply that answer by 1. but multiplying by 1 changes nothing. So I can actually rewrite my general term as follows. Is everyone okay with that? Just know that I didn't multiply the 1 by the 2. I multiplied the 1 by the whole 2 to the power of n minus 1. So when I go to write this in sigma notation, I would write my Greek letter sigma, and I would put my general term here. Now, here's where people get confused. How do we get to, like, where do I start and where do I finish? My first and last. We'll know that this represents term 1. The 2 would represent term 2. The 4 is what? Term 3, term 4, term 5, term 6, and term 7. I'm not putting a 1 here because the first term is a 1. I'm putting a 1 here because if I put a 1 into this formula, what's 1 minus 1? 0. Anything to the power of 0. 2 to the power of 0 would be what? 1. So I start by putting a 1 in. It gives me my first term 1. If I put a 2 in, 2 minus 1 is 1. 2 to the first would be 2. If I put a 3 in, I'd get a 4. A 4 in, I'd get an 8. If I put a 5 into this general term, I'd get a 16. A 6 in, I get a 32. A 7 in, I get a 64. 7 minus 1 would be 6. 2 to the power of 6 would be 64. Start at 1, stop at 7. Is that fair? That is how I would write that in sigma notation. Anyone know what that sum would be? Okay, 64 and 32. That's going to give me 96. This would be 20. 96 and 20 is 116. 8 and 2 are 10. That's 126. And one more would give me 127. Is that fair? It is a sum. I added the terms of that geometric sequence, or I added the terms in this series. Now, I do not believe you have this, so I'll give you a minute to copy that down. All right, the question says, write the following series in sigma notation. It doesn't tell me to find the sum. The sum would be 10 and 25, 35, and 5, 40. That's what it would equal. But they want me to write this in sigma notation. So, like, when it comes to writing it in sigma notation, I know I need the Greek letter sigma. What do I put right here? What's going to go right there? The general term. Well, let's figure out what the general term is. What type of series do I have here? What is the A value? What is T1? 2. Wicked. It's the first term. Five terms in that series. Does it have a common ratio or a common difference? Common difference. We can see that right here, okay? But you can also check 5 minus 2, 8 minus 5, 11 minus 8, and 14 minus 11. They all equal what? 3. How do you find the general term in a arithmetic sequence? We use the following formula. I'm going to fill a 2 in for A. And I'm going to fill a 3 in for the common difference. And when I work that out, what would we get? I'm going to multiply the n minus 1 by 3 first. So this is going to say 2 plus, what's n times 3? And what's negative 1 times 3? When I group my like terms, I end up with the following formula. 3n subtract 1. So that's what I'd put over here on the right. I'm going to go from n equals. What do I put here? A 1. And what do I put up top? A 5. Good, Brody. By putting a 1 in, 3 times 1, 3 minus 1, I would generate a 2. By putting a 2 in, 3 2s are 6 minus 1, I'd get 5. Put a 3 in, 3 3s are 9 minus 1, 8. 3 4s are 12 minus 1, 11. 3 times 5 would be 15 minus 1, 14. N1, N2, N3, N4, N5. Start at 1, stop at 5. A lot of people get confused. They see this first term as a 2, so they want to put a 2 down here. Okay, that is my answer. That is equal to 2 plus 5 plus 8 plus 11 plus 14, which we said was 25, 35, 40. They asked me to write that series in sigma notation. That's what they want for the answer. What's in the box? Sigma symbol, general term, your index is n. You're starting at 1, you're stopping at 5. Okay? All right, couple questions to try. It says find each sum. If you flip your sheet over, they should be on the back. What am I starting at? What am I stopping at? So I should go 1 squared, 2 squared, 3 squared, 4 squared. What should I put between all of these? Why? Because the sigma symbol means calculate the sum, add. What's 1 squared? What's 2 squared? Plus 9 plus 16. 4 and 16 are 20. 1 and 9 are 10. 20 and 10 are 30. That's the sum. That's what it asked me to do. The instruction said find each sum. Okay. Everyone all right with that? I can move down to this next one. Let's do some mental math. Start at 1, stop at 5. What would the first term be? What would I get if I plugged a 1 in for n? What's 3 times 1? Plus 2. 5. If I fill a 2 in, 3 2s are 6, plus 2, 8. What would I get if I filled a 3 in? 11. What would come after the 11? 14. And you can probably see the pattern, 5, 8, 11, 14. The last one should be a what? 17. How did I get the last one? I filled a 5 in. 3 5s are 15, plus 2, 17. Add these together. 11 and 14, 25. 8 and 17, 25. 25 and 25 is 50. Plus 5, what do you get? 55. All this is trying to show that this is the third term, correct? So that means I plugged a 3 in for n. 3 times 3, 9, plus 2, 11. That's how they got the 11. Start at 1, stop at 5. Doesn't have to start at 1 and stop at 5. Doesn't always have to be 1 on the bottom for these types of questions. If I said find the sum, and I said n equals 3 to, let's say 7. Suppose my general term is n squared minus 1. this would mean 3 squared. Start at 3. And stop at what? So I'd go 3 squared minus 1, 4 squared minus 1, 5 squared minus 1, 6 squared minus 1, and then 7 squared minus 1. So you don't have to start at 1. Okay? Start wherever they tell you to start. Stop wherever they tell you to stop. 3 squared is 9, minus 1, 8. 4 squared is 16, minus 1, 15. 5 squared, 25, minus 1, 24. This would be 35, and this would be 48. If I were to add these, okay, 8 and 15, 23 and 24, that's 47, 52, 82, 90, and 40, 130. Someone want to double check that? 8 and 15 and 24 and 35 and 48. $130. Okay, and that is that. You can go to work on your sheet, do questions or do all questions. I think there's just 2 questions, but multiple parts.